G'day there again everyone. I just wanted to do another update on this Ambient Solar today. I've removed the 2N22 transistor here and I've replaced it with a Germanium AC141K. It has a much lower triggering threshold. You can see hopefully on my scope. We are oscillating. I have this multimeter hooked up across the solar panel leads. And I'm getting just over 100 millivolts off that solar panel into my circuit. And it is oscillating. Let's see if we can get that where you can see it. Hopefully the reflections aren't going to be too bad. There we go. And what about, I want that in the shot too. It's going to kill the oscillation at pretty much 100 millivolts it starts up. Which is pretty decent, I reckon, getting some oscillation off 0.1 of a volt. The output's absolutely pathetic. If you can read the max there, it's about 120 millivolts, so I'm picking up an extra 20 millivolts. It's hardly worth noting. It's just the oscillation I want to show you there. Well, I should point out that these panels have really poor output. So I have one here hooked up, short circuit, in the shade. We get 1.3 volts, 1.2, and $500 microamps in the shade. So there's our problem. We've got no amps. Alright. Now I point my little light at this, it'll probably go up. No, still. There we go, if I point it outside, it does go up a bit. We'll get some more amps off the thing. Okay. So, I am going to try, hopefully with one hand, to hook this second panel up in parallel. And let's see if we can get some actual voltage amplification out of this thing. And it's not wanting to play the game. I'm just going to put the camera down for a second, guys. Sorry about this. There we go. I have the second panel in. Our voltage has hardly gone up because I put it in parallel. We do have some more amps. And ooh, isn't that interesting? We're going to have to scale this scope out. And now we're getting over 0.6 of a volt out. Well, about 0.6 of a volt max into our cap. And we're also getting minus 0.23, so we should be getting about 0.7 of a volt into that cap. So as you can see with that, that's still with that same 100 millivolts trigger threshold. And my scope's going to let you see it. You can see I've got voltage DC here. The scope's not 100% on its calibration, but it's saying about the same, 96 millivolts. I'm just going to put my hand in front of those panels and see what it takes to kill it. That's still oscillating now with the extra amps at 80 millivolts. Okay, from 80 millivolts I'm getting 120 millivolts out. I have my hand pretty much over those panels. There you go, I've got to hold my hand nearly flat on those panels to kill the oscillation at 50 millivolts. So let's just hold this back here and we'll see when that starts to oscillate. I'd say that's oscillating at about 60, 65 millivolts. I'll change that scale again so you can see it better. And we'll repeat. So I'm now on my smaller scales. Pretty much 60 millivolts. We're getting some oscillations. Okay, that's all I wanted to show you for now. Thanks for watching.